Custom Tables and Columns module. As part of this module, we'll discuss custom tables and custom columns. These custom objects are used for data transformations inside the Sisense infrastructure. Custom tables are artificial tables which are constructed out of existing data. This example shows a fact table that contains user transactions in different stores. Say a customer's KPI is querying the sales amount or the number of products purchased from one store, we could pivot the original table into a completely new table. The data in the new table could easily answer the KPIs. Having the data transformed in the data model means that the aggregation is performed during the ETL process rather than during the widget load. Custom tables are only available for Elasticube data models, as creating them may require a great amount of work. To create a custom table, you'll have to construct a SQL query. The custom table would then contain the query's results. Common examples for custom tables are creating a dimension table out of a fact, narrowing down a date dimension to a smaller date range, a duplication check or list to avoid many-to-many relationships, and much more. Using custom tables correctly will reduce the amount of work performed by your dashboards every time they load. To create a custom table, click the plus custom button at the top ribbon of the data model. Choose the Add Custom Table menu option. Next, compose your SQL query and save it. Note, the menu also shows the new Custom Code button, which allows creating custom code to generate data. The custom code topic is covered by the dedicated model. The following example shows how to generate an employee dimension table out of a purchase order fact table. Aside from the employee ID, we also perform various aggregations that are going to be used throughout the dashboard. The next few slides show examples for well-known custom table use cases. The following custom tables are examples of how to create a dimension table out of an existing fact table. As employees, products, and vendors are measures that we might want to filter, they must be exposed to the users as dimensions. The following custom table is an example for how to narrow down a date dimension. As the default date dimension ranges between 1950 and 2050, we might want to narrow down. For example, first example shows that we narrow down the date dimension by using a fixed date range. In this example, we narrow down the date dimension by using a fixed start date. In this example, we narrow down the date dimension by using a dynamic start and end date using the data in the table. In our last example, we narrow down the date dimension by using dynamic start and end dates from data from multiple tables. The following custom table is an example for how to identify duplication of keys in a dimension table. For example, we count the number of keys, the number of unique keys, and the number of null keys. To make sure our dimension table keys are valid, verify that the number of keys equals to the number of unique keys and that there are no null keys. The following dimension table shows us 3 duplicates. Say we did find duplications. The following custom table is an example for how to identify the duplicate keys. Any key shown more than once will be listed in the following custom table. Moving on to custom columns. Custom columns are artificial columns added to an existing table to enrich it. The data in this column is constructed out of existing data from the same or different table. This example shows a fact table that contains user transactions in different stores. Say the customer's KPIs is summing up all sales. Adding a total sale price column which takes the store discount into consideration, will make the calculation easier. Different from custom tables, custom columns are available for all data model types. The calculation of a custom column can be either a formula or a SQL statement. Common example for custom columns are performing a lookup based on a different table, performing a calculation based on data in the same table, fake or surrogate keys, numerical date representation, also known as datenum, ranking for slow changing dimensions, and more. Utilizing custom columns correctly will reduce the amount of work performed by your dashboards every time they load. To create a custom column, click the plus column button at the top ribbon of your table view. Next, compose your statement and save it. The following example shows how to generate a total purchase cost column based on two existing columns. Custom column may be easily identified by the lightning logo it has next to its columns icon. A custom column is similar to a left join operation. Using a custom column rather than a custom table saves space. The next few slides show examples for well-known custom column use cases. The following custom column shows a way to look up a value in a different table. One way to implement this is by using a SQL statement. Another way is by using a lookup function. Another well-known use case is using custom columns for fake keys. Fake keys help us connect facts and dimension tables that don't logically connect. In this example, the customer's dimension is connected to the purchases fact table. This connection isn't logical as the company doesn't buy products from customers. They buy from vendors and sell to customers. Custom columns can also be used to create surrogate keys. Surrogate keys help us connect tables that require more than one key. In this example, an individual country, vendors, and products aren't unique. However, concatenating them creates a unique key. This assists us as best practices instruct to connect tables based on a single field. A datenum field is a numerical representation of a date. A custom column can help us calculate the datenum based on the date field. This assists us as best practices instruct to connect date fields based on numerical values. Connecting dates this way makes the join operation cheaper in terms of memory and processing power. The last well-known use case includes a ranking mechanism that ranks row based on a given field. In this example, we have a dimension that includes items and their price. Each price change is reflected in a new row with an update date. Adding a ranking based on the product ID and the update date allows us to understand the order of price updates. This ranking system places the most recent update as rank number 1, which makes it very easy for aggregations and dashboards. This is it for now. Thank you for watching this module.